So here's the project we did for the course Intro to Machine Learning. The project is a multi-class sentiment analysis on movie reviews. First, I'll introduce a little bit about sentiment analysis. It uses natural language processing and text analysis to identify and extract information in source materials. It has been a very popular research area in machine learning. It helps analyzing and understanding written words such as social media posts on Facebook, customer reviews on Amazon, or in our case, movie reviews on IMDb. By processing information in the movie reviews, one can predict sentiments of the authors, such as whether it's positive or negative, or in our case, a 3-class rating prediction system. So why would anyone want to implement algorithms to predict ratings based on the words in it when the ratings are already available? By starting out from predicting ratings, we can essentially aim to understand these words and what consumers care about, and improve customized user experience. We can do things like identifying the reasons behind a great success or failure of a movie, or clustering the reviews to predict the types of movies certain people likes based on user characteristics. A lot of previous research has covered work in this area, such as Peng and Lee in 2005, who used metric labeling in the multi-class classifiers output, and Roberts and Ann in 2014, who analyzed the Kaggle review database and worked on binary labeling.
We used the Cornell Movie Scale Rating dataset for this project, and the different ratings were divided into 3 classes as shown in the table. We tracked different features like TF-IDF, the standardized count of positive and negative words, the part of speech tags, and also the polarity score of a review based on the strength of the positive and negative words. We faced with the curse of dimensionality problem because the data that we were processing was very sparse. As we can see in the graph that most of the words found in the training dataset were having a very low count. So finally we decided to use a feature consisting of the TF-IDF of a movie review along with the standardized count of positive and negative words, and we also filtered the positive and negative words based on its part of speech tags.
For classification models, we finally used TF-IDF with standardized counts of positive and negative words based on Stanford POS tags. Softmax gave a test accuracy of 72% with a good precision and recall. Multinomial naive Bayes with an additive 1 Laplace smoothing gave a moderate accuracy of 63% with a low recall. SVM with linear kernel and C equal to 1 was used as the feature vectors were already normalized, which gave us the best test accuracy, same as Softmax, with a better cross-validated accuracy of 69.42. The next classifier we tried was AdaBoost. With 400 multinomial naive Bayes classifiers and a learning rate of 1, we got an accuracy of 71.2% with the higher test precision than others. Upon analyzing the errors, we found that the classifiers were least confident in predicting the neutral reviews.
The following diagram shows the distribution in the errors of the 3 classifiers used by us. It shows that the 3 classifiers were not wrong at the same time for some of the training instances. So this inspired us to use Ensemble using these 3 classifiers. The Ensemble was based on a soft voting and used a different weights for these 3 classifiers. By using Ensemble, we got a good test accuracy of 73.6%, which is the highest we got so far, and the cross-validated accuracy was also around 70.42%. This is an end-to-end design of the system that we developed in this project. It shows how we use TF-IDF of unigrams and bigrams, the positive and negative word dictionary, and also a Stanford part of speech taggers to extract feature vectors from our training and testing instances. It also shows an ensemble of SVM, Softmax, and naive Bayes, which was used to classify these feature vectors in one of the 3 classes. This ensemble used highest weights on SVM and Softmax.